Hey Becca, what are we learning today?
Today, we're going to convert polar coordinates to rectangular coordinates. In this video, we're converting polar coordinates r comma theta into rectangular coordinates x comma y. Now when we're doing the opposite, we used the Pythagorean theorem and the tangent formula. The problem with using these two formulas in this reverse scenario is that they depend on both x and y in order to find r and theta. But instead, we have r and theta, and we need to use both values in order to find x and y. So the formulas that we're going to use for this conversion: x equals r cosine theta, y equals r sine theta. And on your own, you can use these two formulas and plug them in to these two formulas in order to verify their accuracy. The first example involves converting 5, 30 degrees to rectangular coordinates x, y. So if we draw our polar coordinates, the angle measurement from 0 is 30 degrees, which will bring us about here. And our distance from the origin is 5. 1, 2, 3, 4, 5. So this is our point, and it rests in quadrant 1. So we'll use our formulas for x and y in order to find the rectangular coordinates. X equals r cosine theta. R is 5. Cosine of theta, 30 degrees, which equals 5 times the cosine of 30 we can find using our unit circle, square root of 3 over 2. So x is 5 root 3 over 2. Y is r times sine of theta, which equals 5 times 1/2. This value again found from our unit circle. So our y value is 5/2. And our xy coordinate together, 5 root 3 over 2, comma, 5/2. And this makes sense with our polar coordinates because since both of these values are positive, this rectangular coordinate falls in the first quadrant, similar to our polar coordinate. We're going to convert 3, negative pi over 4 to rectangular coordinates x, y. Using our equations, x equals r times cosine of theta, negative pi over 4, which equals 3 times square root of 2 over 2. This value is positive because cosine of a negative angle in the fourth quadrant, cosine is positive, and our x value is 3 root 2 over 2. Our y value, r times sine of theta, and sine of negative pi over 4 is the same thing as cosine, but it's negative because it's in the fourth quadrant. 3 times negative root 2 over 2, which equals negative 3 root 2 over 2. Now let's take a look at this on the graph. Negative pi over 4 is in the fourth quadrant because it's only 45 degrees clockwise. And our point right here is a distance of 3 from the origin. So our x and y coordinates are 3 root 2 over 2, comma, -3 root 2 over 2, which makes sense because our x value must be positive and our y value must be negative. In this example, we are going to convert 1 comma 4 pi over 3 to rectangular coordinates x comma y. Using our formula, x equals r1 times cosine of theta 4 pi over 3. Cosine of 4 pi over 3 is the same as cosine of pi over 3, but it's negative, so that's 1 times -1/2, which equals -1/2. Y equals r times sine of 4 pi over 3. And sine of 4 pi over 3 is the same as sine of pi over 3, but again it's negative because we are in the third quadrant. 1 times -√3 over 2, which equals -√3 over 2. Graphing this to verify, our angle is 4 pi over 3, which is past pi, about here, and our distance from the origin is just 1. So our x-coordinate is -1/2, and our y-coordinate is -√3 over 2, which makes sense because both our x-coordinate and our y-coordinate must be negative. In this last example, we're going to convert 2 comma 37 degrees to x comma y. And notice that 37 degrees is not a value on the unit circle, so we're going to need to use a calculator to find this. Using our formula, x equals r cosine theta. Now make sure your calculator is in degrees rather than radians. And if we plug this in, our answer is approximately 1.597. We can do the same for y. R times sine of theta. And if you plug this into the calculator, it's approximately 1.204. Graphing this, 37 degrees is in the first quadrant. It's about here. And our distance is 2 from the center. So our x and y coordinates are 1.597, comma 1.204. Both are positive.
I hope after watching this video that you feel more comfortable converting polar coordinates to rectangular coordinates. If you found it helpful, give it a thumbs up and subscribe because we're posting new videos every Monday and Thursday. Have a great day!